so much for the wonderful introduction, Nabir, and thank you for having me and inviting me to be a speaker. I'm so excited. I'm going to go ahead and start sharing my screen. And can you all give me a thumbs up if you are seeing everything okay? A little quick nod in the chat or something. All right, I see some thumbs up. Thank you. So I realize we have an international audience here. My native language is English, which I realize is not everyone's native language on this talk. So if at any point I talk too fast or you need me to repeat something or say something differently, please do not hesitate to ask in the chat. And I'm happy to repeat or rephrase. And in general, if it's not just a language issue, but maybe a misunderstanding or something, you can ask questions at any time at the chat and we'll do our best to answer those in the moment or save them for the end, whatever seems best for the context of the question. So today we are going to be talking about iterating well with purrr. And I am a little stuck. Okay, so first we're going to start off with an introduction. If you didn't see the links to these slides are in the Google Doc that we shared. And I'll also point out that these are Quarto slides as well, if you're curious about that. And so you can see the source for it as well in the repo. So here's all of my contact information. You can find me on Twitter at pipinghotdata, and I have a website and GitHub. Feel free to connect with me on LinkedIn as well. This material comes from the 2020 What They Forgot to Teach You About R Studio workshop at the 2020 R Studio conference. And it's licensed under a Creative Commons 4.0 international license as well. So for this workshop, if you participated along, there will be some sections where you can actively participate, and to be a successful active participant, you're going to need R. Hopefully it's pretty recent, but please don't go try to update your R right now if it's not. You're going to need RStudio, or maybe you don't need RStudio, but I'll be demonstrating RStudio. And the packages that we are going to be using today are the tidyverse, which includes the purrr package, and also recursive. Here's a list of additional resources if after the talk you want to go and find more resources and reading as well. And I'll also note that there are 86 slides in this deck, and we are not going to rush to get through all 86 slides. I do not anticipate that we'll be able to cover all of the material in 1.5 hours. So I'm going to go at hopefully a reasonable pace, and the material will be there for you to look at after if we don't finish. I'm going to start with a brief discussion of syntax in case there are some things that you aren't familiar with that you're going to be seeing in the slides. So I'm going to be using something called the pipe operator in some of our code. And in 2014, the magrittr pipe was introduced. That is that percent greater than percent pipe. And in 2021, a new pipe operator was introduced. It's called the native R pipe operator. You have to have at least R 4.1 to use the native pipe operator. In this content, I will be showing you the native pipe operator, and there's a really nice blog post about the native pipe operator. And there's also, you can change your shortcut in RStudio to be the native pipe instead of magrittr pipe, and here's how you would do that at the bottom in the footnote. So what is the pipe operator? The pipe operator is an operator that allows you to take the first argument of a function and move it up a line. So for example, if you have a function called whatever, and it takes 3 arguments, arg1, arg2, arg3, when you use the pipe operator, you can pull that first argument out and then pipe it into the function. You're going to read that pipe operator as and then, like a chain of events, like take your arg1 and then do whatever to it. So you can see an example over here with the mean function. We're going to take the vector of numbers from 0 to 10 and pipe it into the mean function, so and then take the mean of it. Here is an image from the R for Data Science Chapter 18 pipes, just to kind of further demonstrate how that pipe operator can enhance the readability of your code. So instead of nesting functions within functions, it allows you to move those, organize those functions linearly, so that makes your code more readable. Another syntax thing that you might see in these slides is something called namespacing. That's when you see the colon. So the colon means we are going to take a package, colon, and then a function from that package, like dplyr colon select. So that's namespacing. What that does is it tells R to explicitly use the select function from the dplyr package, and it can help you avoid name conflicts. For example, there's a select function in the math package. And it doesn't require you to attach the package in advance. So these two sections of code are equivalent: library dplyr, select mtcars, mtg, and cylinder. Or equivalently, you can namespace it on the right-hand side, but without having to attach the package with library, and then you're being explicit about which select function you're using. So we're going to be using the pipe operator and probably some namespacing as well. So let's get into the main content. Before we get into iterating with purrr, let's talk a little bit about iterating actually without purrr. So for this quick demonstration, we are going to be using data from Gapminder. That is from the Gapminder package. And I'm also attaching the tidyverse package as well. If you haven't seen the Gapminder data, what it does, you can see it has 1,700 rows here representing countries over time. So we have measurements from Afghanistan in Asia from 1952 onwards, with a few different variables about that country: life expectancy, population, and GDP per capita. If we take a closer look at the life expectancy of these countries, what we're looking at is all of the countries in Africa, the Americas, Asia, Europe, and Oceania. And we're looking at how their life expectancy changes over time, in addition overlaid with the average life expectancy. So let's talk about how we might be doing iterating without purrr. Here is an example of an operation that we might be attempting to do. I'm going to give you a minute to read through this first. I'm going to stay quiet, so I'm going to start my clock. And I want you to try to figure out, what am I doing in this code? And are there mistakes? And as you think about it, you're welcome to put your answers in the chat, please. All right, I see a couple of people catching errors, and they're calling out line numbers for the errors. Great. So I'm glad a minute was enough for you to wrap your head around. All right, I see one person. Oops, I don't need to start that again. Well, the clock will continue, but that's okay. So I see a mistake in line 8, someone mentioned. So I think here's the mistake: Asia versus Africa, when that intended to be Asia. And then I see an error on line 13 and 14 reported, probably Europe versus Oceania here. So that's not consistent. And then someone else, I think, reported the error down here at the bottom. I think so. Here we're reporting 4 continents, but there's actually 5. So we actually didn't put Americas in this vector here. So you all did great at catching the errors. Did anyone kind of understand what we were trying to do with this code? Want to write it in the chat real quick and summarize? Yeah. Yeah, so we're calculating a range. So for each continent, we're computing the difference between the max and then life expectancy. Okay, and I see also a little bit, I'm gonna start the clock again and let you chime in the chat. So what might be some of the drawbacks of the code and how would you do it instead? You can chime in on either one of these questions in the chat. And I think someone already commented in the chat, one drawback, lots of room for error. Yeah, because we're copying and pasting code and the code is repetitive and it leads to errors when you do that copy and paste effort. And does anyone have an alternative approach they could to minimize this? It's okay if you don't, because in 5 seconds, I'm going to show you an alternative approach. All right, time's up. So let me show you how I would do this instead. We can achieve, this is a form of iteration, right? We are doing the same computation over 5 different continents. This is a form of iteration. And this is a form of iteration you can actually do in a group by statement. So, the topic of today's talk is purrr, but like we don't actually need purrr to do this form of iteration. So we can do gapminder pipe to group by, and we're going to group by continent. And we are going to summarize at the continent level. The max minus the min is the max life expectancy minus the min life expectancy. And here you can see the differences side by side between the group by approach and the previous approach. And you'll notice quite a few differences in the 2 outputs, right? Besides the numbers on the right-hand side being wrong, but it's a totally different format as well. I believe on the previous approach that looks more like a matrix. Don't quote me on that. And you see how all of the values are quoted, like the max minus min column isn't even treated as a numeric value. So there's a whole bunch of different issues with that previous approach that are really smoothed out by the group by approach to iteration here. And let's talk about another form of iteration. So here I'm creating the vector of years from 2017 to 2021 and the location of the RStudio conference, of the RStudio conferences. And I'm writing a for loop in order to print out that the 2017 RStudio conference was in Orlando and the 2021 RStudio conference was in remote location. It was online last year and all of them in between. So we achieved this with a for loop. But does anyone know of other ways to do this beyond a for loop? And I'll just give you a little bit of time to write it in the chat if you have any ideas. If you're looking at my slides and you see that this has a scroll bar, it's because the code was extending slightly off the window pane here. All right. I do not see any brave souls with suggestions in the chat, but there are a couple of different ways that we can achieve this. So first is using the paste function. So the paste function will actually do this for you without any for loop explicit iteration. And the glue function will actually do it for you as well. So some functions are actually vectorized in R, which means they will operate over each element in the vector, and they will take care of that iteration for you in the background as well. So I think when you're new to R, it's hard to figure out what approach is best for which context. But I just wanted to point out that anytime you need to iterate, it doesn't necessarily mean you need to go directly to a for loop, or you need to go directly to a group by or some other functions or purrr. There might be other ways that are more natural for the context you have. I'll pause there briefly to see if we have any questions before I move on to introduce purrr. Batul or Abir, are there any questions in the document to be addressed?
No, we don't have any so far.
Okay. So let's talk about purrr then. What if you really do need to iterate? What if a group by approach isn't going to cut it, or maybe leveraging some of those vectorized functions or any other iteration tools that might be out there? So for this, we can use the purrr package. It is part of the tidyverse. Purrr enhances R's functional programming toolkit, and it is a core package of the tidyverse. So you can access the purrr package either by installing the tidyverse package and then attaching it with library. So it's, if you do tidyverse, it's going to install purrr and load purrr and much more. Or if you just want to work with the purrr package only, you can install purrr and library purrr. An alternative to purrr that predated purrr in base R is the apply functions. So the function we're going to be focusing a lot today on is purrr map, and is most closely equivalent to the base L apply function. If you want to read more about the differences between map and L apply, you can see those in this Jenny Bryan tutorial linked right here in the footnote. There are a lot of advantages to map over L apply, and one major one is consistency in outputs. And the data that we are going to be using for our demonstration purposes today come from the recursive package. And what that recursive package does is it has some built-in data, one for Game of Thrones, abbreviated to GOT, so there's GOT characters, and some data related to Star Wars. So we have multiple instances there called Star Wars people, Star Wars species, and a few other things. I'm going to jump over to R real quick just to demonstrate how to get help on this. I'm going to copy my code from that little button. And so we are going to, I'm probably going to need tidyverse. So I'll just go ahead and write that up there. Library tidyverse, library recursive, and we're going to look at our help for our recursive package. And you can see here the different data sets in here. So we have Game of Thrones characters are the ones we are going to be using a lot, and you can also focus on these SW as well. And the format of this data is actually a list. We are going to need to get comfortable with lists. I think if you're coming into data science, data analytics, you're used to working with data frames probably, and probably not as much used to working with lists. But a list is a really handy vehicle for different types of data because it can hold almost anything. You're probably used to looking at columns in a data frame that are logical integers or numeric, like either double or character. But a list, these are all different types of atomic vectors, and a list is a generalized vector that can hold almost anything, and that's what we're going to be working with today. And if you've ever worked with lists, it might feel a little bit like this, like you see the water in the glass and you are just so thirsty and you just want a sip of that nice cold water and you can't figure out how to get it out. And so hopefully the tools today will help you work with those lists a little bit better. So we're going to switch back over to R. And we're going to do a little bit of live coding to figure out how we are going to explore our lists and make sure we're comfortable with that. So like I said, we're going to be starting with this Game of Thrones characters. And the first thing I want to point out is that you can actually open that in the viewer by using View Game of Thrones characters. And you can open that object into something that's clickable and you can navigate on. So we can just take a quick skim of this object here, and we can see that this is actually a list. And it's got, if we scroll down, it's got 30 things in there. And each of those 30 things also has 18 things. We can drill down on it by clicking this blue arrow, and it'll tell you what those 18 things in each element is. So for each Game of Thrones character, you can see that we're getting some sort of URL, an ID, a name, gender, culture, allegiances, and things like this. I'm going to go back over to my document here. So one thing you can do is view it to view that object in your pane there. Another handy thing to get used to any object and familiar with it in R is stir. So, and I always spell that wrong. So Game of Thrones characters. So we can look at the structure of those Game of Thrones characters. And it's handy, but it also printed out a ton of information. I'm going to clear my console and print it again and go back up to the top of my console so you can see where it started. So just kind of mimicking what we saw in our viewer pane here, that we have a list of 30, and each list of 30 also has a list of 18 in it as well. But when we do stir, everything is printed out. If you want to just kind of confirm how many lists are at the top level there, you can do length GOT cars, and we're going to say that, okay, we've got 30 characters in this list. And maybe you want to kind of take a closer look at what's in a single character. It might be helpful to run stir on that single character. So stir Game of Thrones cars, and just kind of look at the first character in that list. And you'll see, let's see here, that information printed out there. So we have 18 elements of that list in the first character for Theon Greyjoy. All right. And so back to the exercise at hand, the question we had, I believe, I'll make sure, how many elements are in Game of Thrones characters? We've gone through that. So who is the 9th person listed in Game of Thrones characters? So one thing you can do here is, if you're in your viewer pane, you can go down and kind of click on the 9th person and see that is Daenerys Targaryen. Or a really handy button in the RStudio ID is this little arrow over here, which will kind of bring that code down to the console, so you can then extract that element in the console. And when we do that extraction in the console, we can now bring that element, print out that list, sublist for Daenerys into the console. So now you can see all of the information about Daenerys Targaryen. So just to kind of reiterate, we did Game of Thrones Cars 9 there when we followed that viewer link. And I also kind of want to show you what happens if we do a single bracket instead of a double bracket. And you can see the printout looks a little bit different. So does anyone know the difference between the single bracket and the double bracket when we're working with lists? It's tricky when you get started and you're learning it for the first time. But the single bracket is actually what we've executed here. And you can see there's like some additional nesting that looks like it's happening. And that's actually returning a sublist, whereas that double bracket is actually going to return the contents in the list. So the double brackets are often much easier to work with to dive in to the contents of the list rather than returning a sublist back out. And hopefully I can give you some visuals right now that'll help explain that a little bit better. So these are some of the commands that we just explored. And let's talk about that single bracket versus the double bracket when we're looking at lists. So imagine X is a list and it's a train carrying cars. And if we do X double bracket, we're returning, or X single bracket for the first element, we're returning a list back. So we're getting the container, the train car itself with the elements in it. But if we do X double bracket 1, we don't get the car anymore, the train car itself, we get the contents of the car. And another visual representation of that is using the pepper shaker analogy. So again, if X is our list and it is this pepper shaker containing pepper packets, if we extract the ith element of that list, we are going to get to the container around the elements extracted back to us. So that sublist is going to come back to us in terms of the container and the pepper packet. But if we want to dive in and just get the contents of that container, that's when we need to use the double bracket. So hopefully that is clear to everyone. And I will certainly pause for questions before we move on to the next section.
We don't have yet any questions in the Google Doc. I was just going to mention for people, do feel free to add your question even in the Zoom chat if you want. You can also voice out your question if you have something to say.
Thank you. All right. So now that we've talked about how to iterate without purrr, and we've talked a little bit about how to work with lists, now we're ready to get started to iterate with purrr. So when we iterate with purrr, we are going to be, the first function we are going to be using is called the map function. The map function takes a first argument of .x and a second argument of .f. And what this means is for every element of .x, do .f. So we're going to input some .x and we are going to apply some function .f. And so you can imagine if your .x is your minis, and we want to put some antennae on our minis, we could map the function antennate over our minis. So here our minis would be our .x and our antennate would be our .f. And we would do that iteration in one swoop. Here's another visual representation of it, which comes from the Advanced R Chapter 9 Functionals chapter, which you can see linked in the footnotes here. So again, we are putting some object.x into our map function. It could have multiple things in it. We're applying a single function f, and that's going to result in that function f being applied to every single element of our x object. Behind the hood, if you actually had the urge to look at what's going on, it's actually basically a for loop happening in the background when you're doing the map. But it's a little bit noisy when you look at that for loop. The map has much simpler syntax to execute yourself and makes it very clear what it is you're iterating over, that .x, and the function you are applying to do that .f. This is called functional programming, which is really just obscured and hidden when you use a for loop. It's not as clear what is happening immediately. So, I mean, per map is actually a nice way to write a for loop that kind of can reduce clutter in your code and make it harder to produce errors. And a nice little quote from Jenny Bryan is that someone out there has to write a for loop. It just doesn't have to be you. Like, I very rarely write for loops anymore. All right, so we are going to do a workflow demonstration back in our R console. And our objective here is we want to figure out how many aliases does each Game of Thrones characters have. So we're going to map over the Game of Thrones characters, like we know that is the object we are working with, but what on earth is the function we need to apply to this map? So what we're going to be doing over in our console is we're going to do this for a single element. We're going to figure out the general recipe or pattern as we do this for a single element, and then we're going to drop it into map to do it for everything. All right, so now I'm going to make some space here, clear out my console so everything looks a little clearer, and we're going to do a little workflow demonstration. All right, so let's do this for a single element. So remember, we want to, I'm going to start with Daenerys because we were just talking about Daenerys. And we want to look at how many aliases Daenerys has. So this is Game of Thrones characters 9. We already remember that's Daenerys, and she's got this element here called aliases. So she actually has quite a few aliases. And the way we can extract the aliases out is we can do another set of double brackets and call the named object aliases. So these are the 11 aliases of Daenerys. And now if we just want to know the number of those aliases, we can wrap that in a length statement. All right, so here we know we have 11 aliases. And now let's say we want to do this for a different character. So we want to do this for, let's see, character 13. So character 13 over here is Asha Greyjoy. We are going to look at Asha Greyjoy's aliases, and she's got 2 here. And I'll just substitute this code as well. And so here we kind of can see the general pattern, right? So we're digging into the character that we want to look at. For the character that we want to look at, we're pulling out the aliases, and then we're wrapping that in a length statement. So if we kind of write out the pattern, maybe another way you can think about writing that out is what is the thing that we want to operate on? In this case, the thing that we want to operate on is, like, let's say Game of Thrones characters 13. That is the thing we want to operate on. That's going to be Asha right there. And then the operation we're doing that to that is we're doing length.x of our aliases. All right, and so now we are getting out the length, the number of aliases that Asha Greyjoy has. So that's our general recipe. And now what we're going to do, now that we know our general recipe, is we're going to drop it into a map. So now we're going to map all of Game of Thrones characters. That is our objects, that our list that we are iterating over. And we are going to apply this as a formula. So length.x, quote, aliases, double bracket, quote, aliases. And so the only difference I'm doing here between line 25 and 27 is adding this tilde, which means we're writing a formula, which is shorthand notation for an anonymous function available to you in a purrr package. I believe I am missing a closed parentheses there. All right. And now we have, for every single, all of the 30 characters in Game of Thrones, we now know how many aliases they have. So to repeat that, what we did is we worked on a single element. Then we worked on a second element to kind of figure out the pattern. We found that the general recipe is we're taking the length of the aliases of something, the thing, the .x. We just want the length of those aliases for each element of Game of Thrones characters. And then we drop that into a map statement using the anonymous, using the formula notation. That was a lot to take in. So I'm very happy to take questions. If you have any, please do not be shy.
Yes, I think we have a question. What is an anonymous function?
Okay, so what's an anonymous function? That is a great question. I have an answer prepared for you already. So if another question rolls in, please feel free to ask. This is kind of what we just went over in the live coding, and it's here for your records as well. Did it for one element, we did it for another element again, and we found the general recipe. And then we dropped it into a map. So what is an anonymous function? So when we use that tilde or that formula, it's a shortcut for an anonymous function supported in purrr, in the purrr package. Excuse me for, oh, I was trying to get a mute. All right. So an anonymous function is meaning that you write a function, but it doesn't have a name, and you're just writing it inline in your code, and you're not saving it as a named function. There's actually 3 ways you can specify anonymous functions that I know of in R. One second. So the first way is what we just discussed, using the formula notation, which is supported in the purrr package. Another way you can write an anonymous function is writing function x and then writing the function definition after it. That's supported in base R back for all time, as far as I know. And another way of writing an anonymous function was more recently supported in R 4.1.0 using the \x notation instead of function x. So you can see they're both kind of abbreviations on this base R way of writing anonymous functions. And so these are just ways you can write functions on the fly without saving them as under a name. Does that answer your question? Is the tilde necessary? Yes, it is necessary. This tilde is necessary to have this map work. It's a way of specifying that it is a function. Are there any other questions?
I don't see any right now.
Okay. All right, it's actually your turn to work. So I'm going to give you a few minutes to work on your computer. And so I see one more question in there. It says, please explain .x again. So let me go back before I give you a turn. So I'm going to go back a few slides. So remember that at the heart of it, .x is the first argument that the purrr map function takes. It is the thing that you want to iterate over. And so maybe that's not the .x you were referring to. Probably it was the .x over here. So it is the first argument of your purrr map function. And one way you can find that general recipe is when you're kind of looking at your code and you're replicating things over and over again, just to kind of get a feel for it and make sure you're doing things right. You can substitute in .x for an individual element. So in this case, an individual element is a certain Game of Thrones characters, like Game of Thrones characters 9 for Daenerys or Game of Thrones characters 13 for Asha. It is an individual element. And when we are substituting that out for each individual element, we can put that into kind of our recipe for how to create a function. So this is saying when we put it into, I guess it's a pronoun, you can think of it as it. It also means the current element. So when we are doing something, an operation like this, we're mapping over an entire list, Game of Thrones characters. We know we've got 30 characters in it. And so when we specify that in an anonymous function, we're saying do this for the current element. For the current element, Game of Thrones characters 1, pull out the aliases and take the length. For Game of Thrones characters 2, pull out the aliases and take the length. I hope that helps.
If anyone wanna ask to repeat any kind of the question, okay, very helpful and clear. Brilliant. If anyone got any other question, please do add it in the chat. Yeah, thank you, Shannon.
Thank you. And thank you for your questions. Please keep them coming. They're very good questions, especially if you're looking at this material for the first time. And now it is your turn to try. The best way to get proficient at new ways of coding is to actually do it yourself. And so what I want you to think of is how many of something does each character have? So if you like Game of Thrones, you can work with the Game of Thrones characters. And a suggestion is you can look at their titles or their allegiances. And if you're into Star Wars, you can look at SW people, and maybe you can look at vehicles or starships. And so don't forget the syntax we just used is there for your help, to help you. And why don't you just have a play with it for a few minutes? If 5 minutes is painful on Zoom to work silently together, I am happy to cut it short, but I do want to give you some time to try yourself. So until I see a signal otherwise, I'm going to let this clock run down to let you all play. And while the clock is running down, I'm going to be right back and I'm going to refill my water. If you have any questions, you're welcome to pop them in the chat. Or if you found a solution and want to share your code and your solution, you're also welcome to pop that in the chat. I see Stephanie in the chat has successfully explored Star Wars and found only one Star Wars character has more than one vehicle. Interesting find. If you have any syntax errors as well, you're welcome to pop your code in the chat and say, this isn't working, I don't know why. forgot the comma on the first try. Yeah, it's really easy to miss little things like that. Thank you. If you have any interesting findings about Game of Thrones characters or Star Wars people, feel free to pop them in the chat, something surprising or not surprising, code that's working or not working. Yes, as Batul said, please feel free to share code that's not working if you're stuck on anything at all. We can do our best to diagnose on Zoom. All right, so that is time. And just for the sake of completeness, I will pop it over to R just to kind of show you a little bit. So here I was asking about Game of Thrones characters, and maybe we want to look at their titles. And let's see here, how many titles they have are going to pop up, or we want to look at their allegiances. And all those numbers of allegiances are going to pop up, and we can do the same thing for the Star Wars characters as well. All right. So that was great and all, but one thing you might have noticed when we were looking at this output, maybe I'll go back to my slides instead of the R console. What does this output even look like though? What am I getting back? Is this like a format of data that you're used to working with, or is it kind of confusing output? I mean, I think, oh, thank you for sharing, Aisha. Titles for Game of Thrones, and found that characters 9, 19, and 20 had the most titles, 5 each. Nice. But when you're like looking through the output, it's kind of, there's some challenges to looking through this output. So when you use map, it's going to return a list. So this is a list itself. However, there are variants on map, and these are called type-specific variants. So you can see here, I've used the variant int to indicate integer. And then instead of returning a list, it's returning a vector of the integers, which is probably an object that you are more familiar with working with. So there are these 4 type-specific variants. So we can do a map for logical, integers, doubles, or characters. And that's going to return an atomic vector of that specified type. So we're going to get a nice compact vector instead of that nested list structure. So these can make things much more natural to work with. And so now your objective for each of these. Remember, you can copy the code using this little clipboard here, and you can grab it from my slides links that's shared in the Google Doc. And why don't you take a few minutes and see if you can replace maps with the type-specific variants. Remember, those are integers, int, double, dbl, logical, lgl, and characters, dhr, to extract the name of these characters, the hair color, whether or not they're alive, unless you want to skip that because it's a spoiler if you haven't seen Game of Thrones, or the gender of the characters, and how heavy they are. And if you see anything surprising or that you don't quite understand, then please go ahead and ask in the chat. And I'll say that there was one thing in here that surprised me and did not meet my assumptions of what I thought it was going to be. Yeah, I see one person in the chat already found the one that surprised them. All right, so I'm going to copy this to the clipboard and switch over to R and just work through it myself quickly. So in order to successfully execute these type-specific variants, you do need to know a little bit about what's in your data, right? So if we're extracting name, we kind of need to know some expectation that it is a character vector there. So let's go back over. Since name is a character vector, we can extract that with map.chr, and then we have a character vector returned. That's going to work for both Game of Thrones characters and SW people. What color is each SW character's hair? Well, we can go ahead and make some sort of intelligent guess that is a character vector as well. And it is, and you can see the different hair colors as well. Is the Game of Thrones character alive? For that, you'll need to know exactly what is in that alive content. So here you can see that the type of alive is logical. So in order to map that with the type specific variant, you would use LGL, and then you would return those trues and falses. Is this character female? So here we're evaluating an anonymous formula that's going to return a logical result. So here we can use LGL again for trues and falses. And how heavy is each Star Wars character? So you might imagine mass is some sort of numeric value. So you might try double, or you might try integer. But you see this warning here. It says can't coerce element run from character to a double. So it's actually not stored as a numeric value. And if we do map character there, you can see here it was stored with unknowns written in quotes instead of as like a proper NA. So these are actually stored as character values. Are there any questions on our type-specific variants? All right. You all are becoming pros already. So let's do a little bit more. Like that was the basic of it, right? You're going to do map. You're going to have your first argument as .x, and for every element in .x, you're going to apply or do .f. So what else can we do? So we've already talked about how like lists, they can be like a little awkward to get used to, but they can be necessary. Like they're really useful format because they can hold so much different types of data. And we need to get to know our list in order to work with it. And so just as another review, remember for every element, when we map, what we're saying is for every element of .x, do .f. You can use quick anonymous functions via the formula with a tilde. And the type-specific map variants are really helpful to return vectors instead of lists. One thing that you might notice when you're working with lists is that you might be extracting by name a lot. So what if you want the name of the characters? Well, we can write that in an anonymous formula with tilde, .x, bracket, bracket, name. What if we want to know each character's hair color? What if we want to know if the Game of Thrones character is alive? What if we want to know how heavy each Star Wars character is, right? So in each case, we are extracting elements of the list by name. And it seems like a kind of a heavy lift to just extract an element by name, to have to write an anonymous formula with this notation. So there's actually a shorthand to alleviate that heavy lift. So when you're thinking about what does .f, the function, accept, so maybe the first thing you can think of it accepting is some sort of named function. Like if we created a function called getName, where we're extracting the name element out of that list and we can apply it, like that's one way you can specify functions in .f. Or just like we've been doing, you can specify those anonymous functions. But you should also know that there's a shortcut just to get that named element out. And that is you just write the name of the element in quotes. And that is also going to return all of the names of the Game of Thrones characters. And you can do that by position as well. So in the name element of that list is in the third position. So all four of these syntaxes, 4 different specifications of your function, return the exact same result. I'm gonna pause there, see if there's any questions.
I don't see any question. There's someone that did not unmute. That's it.
Oh, okay. So again, let's say we're working with our mini Lego figurines and they are our list.x. And we want to remove or extract the pants, pull those pants off of our figurines. Again, we can just do that by using our name shortcut. So we would do map minis and extract the pants by putting the name pants in quotes. So now it is your turn again. So I want you to explore the Game of Thrones characters or an SW list and find some sort of new element to look at. I want you to try to extract the whole list with name or position shortcuts for .f. And I want you to try to use some sort of map variant to get a vector as an output instead of a list. So here's kind of an outline of what you might look at. So again, like what variant are you using and what is the named thing that you are extracting, and see what progress you can make. I expect that there will be a couple of stumbling blocks that's going to lead into our next discussion. So stumbling blocks are just as valid and as good to talk about in the chat as things that went well. So please share your findings in the chat as you're working on it. Again, as you're working on this, I'll just repeat that I expect that some things will go well and smooth and you'll get output with no problems. And I expect some things might actually result in errors. So share your output or your code that's working well or code that's not working well in the chat. Stephanie, I think I see an interesting comment in there. Can you share the code that led to that error? Maybe we can look at that together. I think you shared the error. Yeah. All right. Okay, perfect. So Stephanie shared some code that gave her a little stumbling block. So maybe what I'll do first is I will maybe share an exercise that won't give you a stumbling block. The idea was for us to explore different ways of extracting using the name shortcut or position shortcut. So for example, if we're looking at the Game of Thrones characters again, and maybe we want to extract the culture element for each Game of Thrones characters, then we can see the culture for those different Game of Thrones characters. And since the culture was the fifth element of each sublist, you could have done that equivalently with just putting in the number 5, and you will see the same result. So it worked great for culture, but maybe there are some other things it just doesn't work as great for. So I'm going to take Stephanie's example, map CHR films. And so, all right, we have an error. Error in stat bad type. Result 1 must be a single string, not a character vector of length 5. Okay, so when you hit these kinds of errors, one thing that might help to kind of backtrack and diagnose is to take that type specific variant off. So what happens if we take that off? Well, when we take that type specific variant off, okay, we are in SW people, so it's not 30 characters anymore, it's our 80 or so Star Wars characters. I'm gonna Control L and run that again so I can go to the top of that output. And so we're extracting all of the films that these Star Wars characters are in, which give different API hits. But can you see like what's kind of different about each of these elements, each of these characters? What might be triggering this error that we got? Result 1 must be a single string, not a character vector of length 5. Does it make any more sense when you see this full map now? What is it expecting that it's not getting? I mean, it is expecting just kind of one element for each character. And some of these characters do have just one film listed, but some of these characters have multiple films listed. So that's one problem. So what do we do when it's not just a single element that we want to extract? In that case, our type specific variant isn't working, but our regular map is in terms of the list. And another one that you might see, another different type of error that you might see is when we're looking at SW vehicles. So let's do map underscore CHR SW vehicles. And let's look at pilots. And it says result 1 must be a single string. It's a different type of error, but it's kind of the same error, not null or of length 0. So it's in the same spirit as the last error we had, but it is a little bit different. And so what's going on here, if we just look at the regular map, you can see that some of these elements are null, like there's nothing there. And that's also causing an error in our type specific variant. So how do we overcome these errors? All right. So a common problem is we're using our type specific variant, but some elements aren't of length 1, just like you saw in those films, or some elements are absent or have lengths greater than 1. So an absent element is like what you saw in the vehicles where you saw the null elements, and those are common problems, and we have tools to resolve those common problems. So if you have a missing element, one solution is to use the .default argument in your map to specify a default value. And if you have elements that are greater than 1 in length, you can't make an atomic vector, so we're not going to be able to squish it into an atomic vector using our type-specific variants. We can use a list, like I showed you, to how to backtrack and just use the regular map instead of the map character. We can squish it into a list column, which we're not really going to focus on in this talk. Or we can just like pick one element and see what happens, like the first element, if that's relative, not relative, but if it's relevant for your problem at hand. So let's see what this might look like. So for example, if we are looking at our SW vehicles and we want to extract the pilots element out, before, remember when we were doing our live coding, we saw that this specified null before. And now you can see that when we use our .default argument and we specify it to NA, now all of our null elements are now written in as NA. So that's one possible solution if you have some null elements, and that can help you use those type-specific variants. Now, this particular element of pilots has another issue, and that not all elements are of length 1. So, you know, we have an NA that's length 1, but we have some vehicle or some pilots here that are of length 2, length 1, length 2. So they're not all the same length, and it's really going to be looking for same length element, so one element. And so the way that we are going to get away this problem is by specifying that we want to extract the first element from those pilots, not all of the pilots in the SW vehicles. And so the way we are going to specify that is with yet another way of writing our .f, and that can accept a list as well. So in this specification, if our .f is a list, we are going to extract the named element of pilots, and then we are going to further extract the first element of those pilots. And on top of that, we are specifying that any null values are getting written in as NA. And now, when we do all of that together, we can use our type-specific variant map character. So just kind of a review, and I will certainly take more questions. There's more shortcuts you can use to specify a function. So another one that wasn't written before, but just so that you know about, you can write in a vector of positions. So C14,1, pilots is in the 14th position of that sublist. So this means we want to go to the 14th position and take the first element. And this is another way of saying the same thing. We're going to specify a list of names and positions. So our .f here is we're going to go to the named pilots element and retrieve the named pilots element and retrieve the first element of it. So many ways you can specify .f. All right, any questions about using the .default or another way of specifying .f before we move on?
Yeah, feel free to voice your question if you want. If you're not comfortable with your English, also feel free to speak if you want Arabic, French. I'm not fluent in either languages, but yeah, I'll try to translate as well.
Okay. So please keep those questions coming. Here's another challenge when you are looking at the results of a map. So we're mapping the type-specific variant of logical. We're going over our Game of Thrones characters, and we want to know the results if they are alive or dead at the end of the seasons. And sorry if this is a spoiler alert and you haven't watched the show yet, but we know some people are alive, true, and some people are alive, false, and we don't know who those truths and falses belong to. So here's another solution for you. I think I'm going to switch over to live coding to make this a little bit more real time for you. All right, so the way we can come up with a solution so that we can know what result goes with which character is we want to work with a named list. So when we're looking at our Game of Thrones characters in our reviewer, this is not a named list. So here, all elements are indexed by their position number. And it's really not obvious who character 1 is unless you dig into that. And so the way we can solve this problem is by putting names up front on our list. So to do this, I'm going to first retrieve the Game of Thrones names. I'm going to save it as an object. So I am going to map character of the Game of Thrones characters, and I'm going to retrieve all of the names using the name shortcut to specify .f. So here now I just have a vector of all of the names, the 30 names of all Game of Thrones characters. So this is kind of my identifier for the different elements of my list. Now to create a named list, I'm going to save this as a new object. I'm going to call this Game of Thrones characters named. And the way I'm going to do this is using an rlang function that's available in the tidyverse called setNames. The first element that I'm going to set the names of is Game of Thrones characters, and the names I'm going to give it are Game of Thrones named. So now when I look at Game of Thrones characters named, it's going to look a lot different in your viewer. So here, instead of having just this position indexing, we now have an identifier of what each element is in our list. And this was really, really handy to work with. In addition, because when you output these type-specific variants or any kind of a map at all, actually, you are going to get those names associated back out. So let's just look at an example. If we do map logical Game of Thrones characters named, and we look at whether or not people are alive. Now, instead of just having a vectors of true and falses, those names of that list propagate through the result. And so now it's easier to see which result belonged to which character. And that's going to be true whether or not you use that type specific variant. So even if you just wanted to return a list using map, those names still propagate there as well. It just makes that output that you're working with much, much more readable, easier to navigate and digest. So these names are going to propagate in your purrr pipelines, and we kind of just went through what this looks like and how to establish it. And I would just say, like, named lists, like, again, are so much better when you're working than unnamed lists. So set those names early, like the first thing that you do, create a named list and enjoy.
I think we have a question.
Okay.
What is the difference between map, apply, and why using map instead?
All right, so what is the difference between map and lapply, and why are we using map instead? So a more in-depth answer is going to be in this Jenny Bryan tutorial right here. We can go ahead and pop that open real quick. And she's saying, like, you can definitely use, do all of this iteration in base R, but there's definitely reasons why you might want to. So the map functions are very internally consistent, and you've got some concise syntax there. So those are the two main advantages. And if you want to look more into depth, I encourage you to read this tutorial. Was there another question?
No.
Would you mind to add the link to the chat? I know it's in the slides, but just trying to navigate.
Yeah.
Thank you.
Also, can link this in the chat. Okay. And just as another example, I know we have 5 minutes left, so I'm going to try to hit a super high level of, like, things to get excited about in the future. Name propagation also works with tibble and frame. So if you want to convert your result and squeeze it into a list column format, which you certainly can, that name propagation with that named list is going to carry forward for you. And tibble and frame is a function I use a lot as well. So just as a review, number 3, we want to set list names early. It's going to make life happier. There's so many ways you can specify that function .f. You can do it with a name in quotes, or with a position, or with a vector of the top level and the next level element placement. You can do it with a list column specification, not list column, but like list specification using the name of the element and then the position, and also using an anonymous formula. And .default is so useful for missing things. And I would say it's not obvious that that argument is there. So definitely remember that one as well. I'm going to skip your turn since we're almost at the end, but if you want to challenge yourself, I certainly encourage you to try these exercises on your own and see how it goes. And just want to leave you with a few minutes of inspiration for your future purrr work. So I don't know, what do you think, Batul and Abir? Should I try to like breeze by some of these topics, or just leave them and take any questions, since we're almost at time?
It depends on you, Shannon. If you feel like you can accelerate a few slides, if you want to take questions, whatever you feel comfortable.
Yeah. If you have any questions, certainly put them in the chat, put them in the document. I will be happy to get back to you, especially if you put your name in there. I'll just say, like, you know, what happens when you want to pass additional arguments to your functions, right? So let's see here. We're looking at the books that are associated with our Game of Thrones characters. Theon Greyjoy was in 2 books. Tyrion Lannister was in 2 books. What if we want to create kind of like one character vector Theon was in 3 books. What if we wanted to create one character vector that smushes all of them together, separated by commas or something? And in a way you would do that with the paste function. And so maybe you think like your first shot might be to like, okay, I'm going to create an anonymous function. I am going to paste every element of .x, and I am going to collapse it with a comma. So I have this like comma separated value of our books. But actually for additional arguments, you can pass those through the dots in your map function. So instead of specifying that anonymous function, here's yet another way of doing it. You can actually pass that collapse argument here, like a fixed argument on the end as well, an argument that applies to every element that you're iterating over. And for your future purrr work, you should look into walk. It's really cool as well for when you want to produce output for like producing tables or PowerPoints or whatever. Walk is super powerful. Map DFR is awesome. You can read in and smush 400 files at once. You can math over 2 or more things in parallel. So what if you've got your hair up top and your minis at the bottom, and these are the things you want to parallel map over? Well, you can do that with map too. So you can take those minis and you can take that hair and you can inhere them. So there's the map 2 variants, there's walk, and I'm going to just squeeze down all the way to the end, just to let you know that there's a whole world of things that you can do up there in purrr, map, map 2, IMAP, PMAP, as well as your type specific variants. So it's very powerful syntax, and I hope that you are inspired to explore the world of purrr now.